Hey y'all, we are checking out 2.5 or rearranging linear equations or linear formulas. So put that at the top of your notes and we'll jump right in. Um, so we've checked out like standard form equations and we liked that because if you plugged in, we know wherever this hits the y and x axes respectively, this point is going to have 0 for y and some number for x. So if we want to find that number, we can just plug in 0 into this y. You get 2 times 0 is 0. You divide by 6, and you get 4. So this ends up being at 4, 0. And likewise, if we want to find the y-intercept, this is none over on the x, but something over on the y. So we plug 0 in for the x-coordinate, and 0 times 6 is 0. So you're just left with 2y, and when you divide, this should be 12. And so this should be 0, 12. We've got our 2 points, bam, bam, we make our line. That's why we like standard form. Sweet. It's not great for other things, like say seeing how things will change, or like looking at the slope. I don't know slope from this right away. Right here I say, oh, that's my slope. So intercept form is nice because you can say, hey, I start here, and I start at 12, and this is rise -3 and run 1. So rise down 1, 2, 3, run 1. There's my next dot. I can graph. So they're both similar in that respect that you can graph, but this illuminates the slope really well, and these illuminates the intercepts really well. With this, I can't really see I can't see where this point is going to be with this one. This one, I can tell that point fairly easily. So sometimes you need to figure out with this equation what the slope is. And if you had slope-intercept form, it's really easy. You just look at where the slope should be. So that's kind of tough, but I'm going to be an optimist about it. Optimist. Because we're going to transform from one to the other so we can find the pieces that we want. So first we're going to figure out how to go from standard to slope-intercept, and then we're going to go the other way. So here are your steps. You isolate the y, right? We want to turn this into this. This looks like slope-intercept form because the y is sitting by itself. You have a number attached to the to the x, sorry, and you have an intercept. So we're going to get this to look like that by doing this. We want to isolate the y, so figure out which part you want to get by itself. Use your fancy integer skills, which we learned last unit, to figure that out. So first of all, like this is a packet. It's being added to this, so we can either remove the addition or remove the division. It's easiest to remove the to remove the addition by subtracting 6x from this side and 6x from this side. 6x plus 2y minus 6x, those cancel out. And on the left side, we're left with 2y. And on the right side, we're left with 24 minus 6x, whatever that may be. Cool? You can then divide by 2 and divide by 2, and you're left with y equals 24 minus 2x over 2. Since it's one big division, you can break this into 24 over 2, this piece, minus 6x over 2. 6x over 2. This is, if you're not sure about that, think about this. 1/5 plus 3/5 is how many fifths? Yeah, it's 4/5. It's 1 plus 3 fifths. And so all we're doing is working backwards and saying, hey, 1/5 is right here, and 3/5 is right here, and this addition is right there. So we're doing that here. We're taking this and saying this is this, this is this, and here's my subtraction. Cool? Now this is really nice, but we need a little bit more work to it. 24 divided by 2 is y is over to this side. Here's y equals 24 divided by 2 is 12. There's our minus sign. And 6x divided by 2 means I have 6 packages of x, right? 6 pieces of x divided by into 2 groups, right? How many in each group? 3x, right? So this really is 3x, and that looks nice, but since we're looking for slope-intercept form, the piece with the x goes first. Here, 3x is negative, so we're going to take this packet and put it out in front, right? Negative 3x. Here, this is a positive 12, so it's going to stay positive 12, right? And so there's your slope-intercept form. Ching, just like we thought. Take that same idea and try it with this example. Pause me and I'll show you how it's done afterwards. Go. All right. So now that you're done with that, let's clear this out of here and attack this piece. All right. Oh, don't look at the answer. Don't look at the answer. We're trying to solve for y, right? So we've got to get rid of this 3x by subtracting. It's positive 3x, so we're going to subtract 3x, 3x minus 5y plus 3x. These cancel, and you're just left with negative 5y. The 5y is negative here. You can tell because there's a big negative sign in front of it, so it's going to stay that way. And here you've got negative 10, and minus 3x sits like that. If you want to rearrange it right now, do it. But now we can divide by negative 5, divide all this by negative 5. Negative 5s cancel out. You're left with y equals, and we're going to play the same game and say this negative 10 over negative 5 minus this 3x minus 5. 3x, sorry, over 5. This negative doesn't pop in twice, it's right there. Oh, and we keep this negative 5. Cool. If we re-rack this, this is y equals negative 10 divided by negative 5 is positive 2. We've got a minus, and this is 3x over negative 5. Cool. If we sort that out, we put this whole piece in front. This becomes negative 3x over negative 5 plus 2 because this is positive. Cool. I like it so far, except minus a negative, right? This is like saying minus negative a half. That dog. Minus negative a half is plus a half. If you subtract a negative, you can rewrite those as plus, right? We're going to do the same thing here. This is minus negative 3x fifths, and those end up just being a plus, so we're going to be left with y is 3 fifths x plus 2. Hopefully the conversion from 3x fifths to 3 fifths times x is okay with you. You could think about it like saying x over 2 or 1x over 2 is the same as saying 1/2 times x. If you're not sure about that, come see me about fractions. Cool, so there's that. Let's check it and make sure we're good. Oop, wrong one. Yeah, 3 fifths x plus 2. Great. It's right here at the bottom. Sweet. So we know how to go from standard to slope.